Hello and welcome to our in-class practice for the day. We were working with 7-3 the last time we were in class, similar triangles. And we talked about, you should have watched the video for 7-4, which is the side splitter theorem. Okay, now I want to go back a little bit and talk about this particular problem, number 6 in our practice packet. So go ahead and open that up to show B and open up this practice packet because this particular problem is very interesting. If you look closely, it says ABC, and let's highlight this. ABC, which is the big triangle, is, the angle. ABC, which is this bottom right angle, is congruent to ADB. Now this is a little bit strange because we do have two triangles here. And I want to highlight this just to illustrate something. If I separated these two triangles, where there's A, D, B, and I highly recommend you do this if and when you see a problem like this. And you'll see this when you have one triangle inside of another, right? You have two different triangles in here. You have a segment that is separating the triangles. Actually, you have three triangles here, but we're going to focus in on these two in particular because these have the congruent angles that is mentioned in the given. And let's finish labeling this ADB. Now, if you notice, this in the blue triangle, ABC is congruent to, in the red triangle, ADB. But if you also notice, angle A is in both triangles, meaning we could prove that these two triangles are in fact similar to each other by angle, right? And if we go ahead and just give some random angles here, if I said, let's say angle B was 100 degrees and angle A was 30 degrees, it could automatically assume that this is 50 degrees. Sorry, I should put this in pink. And we could actually do the same thing here. We could say that angle D is 100 degrees. Angle A would still be a 30 because it's the same angle. And then angle B would have to be the remainder 50. So these two triangles are in fact congruent to each other. Or not congruent, similar to each other. So we could say that these are congruent by angle, and we could actually write the triangle congruence here. So we could say triangle, and this is the tricky part because a lot of things are going to cross over and it's going to look really, really funny. Triangle, and I highly recommend doing this first. Writing the similarity statement is going to go a long way in terms of actually writing the proportionalities. So angle ABC, or triangle ABC, is congruent to, and if you notice I went from 2 to 1 to 0, no angle tick on that last one. So let's do the same thing to triangle A to D to B, okay? And the reason why I say it's important to do this particular step is because then we could actually show proportionality a lot quicker. We could say AB is going to be proportional to AD. We're also going to see BC being proportional to DB, right? And we could show you these are the second and the third, respectively. And then the last one, AC, is going to be proportional to AB. Okay? And all this is saying is we have certain parts of these triangles that are proportional to each other. The red one's obviously smaller than the blue one, and that's how the proportions will actually work in this particular triangle. So there is proportionality here. These are in fact similar. We have to be very, very careful when we are trying to complete when we're solving using this type of proportion problem. So for instance, if I actually put in some values in here, let's say AB has a length of 4, AD has a length of 5, and let's say BC has a length of 7, and then AC is our, let's say this is, 8, and let's say this is our unknown. Okay. If you look closely, we need the length of DB. So right away, I notice we need this particular part of our proportion. So we definitely need this ratio. And we have AC, and we could solve for AC if we really wanted to. And we have AB. We could actually do this with AD as well, and AB. But for the sake of it, I'm just going to use these last ones. And you could solve this proportion using these values, or this exact proportion. So BC has a length of 7. DB is our unknown. AC has a length of 13. Keep in mind that it's the full length of AC. And then AB has a length of 4. And this is going to turn out to be a decimal, which is fine. Or we could keep this as a fraction. This is going to be 28 is equal to 13x divided by 13. And x is equal to 28 over 13. It's not going to be a clean number. I'm going to leave it like that. Okay? But it just goes to show you that these parts are proportional to each other. It's just not lined up exactly as you think it would be. You would think, oh, I have AB here twice. You would think that they would line up perfectly with each other, whether it's on the in the numerator or denominator, but actually notice there are ones in the numerator, ones in the denominator. So be careful with this type of problem. I highly recommend you break this apart. Okay? Now let's get into some side splitter stuff. Okay. For instance, this one. Identify how the given triangles are similar and write the similarity statement. Then find each measure. So we need to solve for x here. And if you notice, we actually have, if you look at this, we have an isosceles triangle, right? Because we have two sides that are congruent. And we could then say that the two base angles are congruent. Similarly, we have the same length. Instead it's going to be 2 and 3. Add up 2 plus 1 is equal to 3. 3 ticks, 3 ticks. And these would also be congruent to each other. Okay? Now, here, we do have proportionality. It's just we have to be actually very, very careful here because we have two triangles. And let me draw this again, a second triangle in blue, because if you look closely, it's very, very tempting to say that this length here is 13, when in reality, it's the combination of these two. So be careful with this type of problem too. It's triangle within a triangle. We have to consider, oh, it's actually a combination of two pieces. So we have a 39, we have the x value here, and then the red triangle, 26, and then we have 20 here, and we could always do this proportionality problem. So we have 20 over x, so from left to right, over, and it was equal to, let's do the blue, 26 over 39. Okay. And here we could actually reduce this and make this 2 over 3. And I'm going to keep this, let's keep this in order. 20 over x is equal to, cross multiply, you should get 2x is equal to 60. Divide by 2, divide by 2. X is then equal to, that's a 2, 30. Okay. So these are in fact, I'm sorry, I forgot to do this. They are congruent or similar by angle. Okay. All right. try another one. Here, we actually have a side length that we're going to be using, and this is actually a good example for the side splitter, because what the side splitter says is that if you have parallel lines, then the sides or the parts that are being, I guess, separated by them, by the transversals, by the parallel lines, are in fact proportional to a second pair or second transversals broken pieces. It's a bad explanation of it, but this is what I'm trying to illustrate, is that there is proportionality. If you actually turn this triangle, it's actually easier to see, but let's do this in blue. The blue 1 tick is proportional to the red 1 tick. The blue 2 ticks is proportional to the red 2 ticks, and we could actually write the proportions. If you really, really want to, you could write it, blue to red. So 30 over 32 is equal to 10 over x. Okay, and this is a proper proportion for this. Now, this is doing some quick math. We could actually simplify this. 15 over 16. Cross multiply, we get 160 is equal to 15x. Divide by 15, divide by 15. X is then equal to, we could actually divide this by 5. So this would have a 3 as a denominator. Numerator would be 32. And that's as far as we could go. Okay? Problem like this. VT. These are in fact similar. We have parallel lines here, and once again we could use our side splitter. So let's break this apart again. Blue, and this is the blue 2 ticks. Red 2 ticks. And this is one where I personally would redraw both triangles, because it can get a little tricky when we're talking about bases, and those are the bases of the triangles. If you rotate this around, we have to consider proportionality properly. So if I looked at this, I'm going to rotate, and if I drew this, a red triangle, blue triangle, and let's call this VUT, RST. This has a length of 14. The red length is actually a combination. ST takes into consider SV and VT. So in reality, this is actually has a full length of 4x minus 1. Okay? And then VT on the other side is just x plus 2. This has a length of 6, and then we could do our proportions. So let's do it. Left to right, 14 over 6 is equal to 4x minus 1 over x minus 2. Doing some cross multiplication, we could actually simplify this. Let's make this 7 over 3. And cross multiplying, we should get 7x minus 14 is equal to 12x minus 3. Doing some math at the same time, 7x's will cancel out. We get 5x. Adding 3 to both sides, you should get a sorry, thought I did some math wrong. That looks 7x minus 14. Let me double check this real quick. 4x minus 1. That is fine. 12x minus 3. 7x. There it is. It's supposed to be a plus 2. So this is messed up a little bit. When I cross multiply, this should be a plus 14. And this is now 17 divided by 5. And x is equal to 17/5. Okay? So you do have some problems like this. take that into some consideration when you're looking at triangles within triangles. In this particular case, we have parallel lines, so you want to consider the side splitter. It's also very, very important when you're working with the bases of them. Okay, in this particular case, we did not have to work with the base because we were working with the sides of them. In number 12, we were actually working with the bases of them, so it's good to split this up into two triangles. Okay, we're going to work more with this in our next class for sure, but make sure you when you're looking at this, you want to see if you're working with the sides using the side splitter. If you're working with the bases, use similar triangles. Okay, if you want to try out the homework, please do so, and then if you do have questions on it, we'll definitely go over it in class. So give that a shot, and we'll see how you do. All right, I'll see you in the next one.